Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Institute of Technology and Management, Gurgaon. This college is affiliated to Mahatma Gandhi University, Rohtak. So guys, this is your first unit of Etce branch and subject is M3, right? So today I will discuss partial differential equation and partial differential equation. I will discuss topic order, formation of partial differential equation, solution of partial differential equation, and so on, right? So let's begin it. Partial differential equation. So partial differential equation, 1 minute, okay, right. So partial differential equation. So first thing, what is definition of partial differential equation? So I told you, or differential equation, sorry. Okay, first differential equation. So differential equation, there are two types of differential equation. First one, ordinary differential equation. Second one, partial differential equation, right? So differential equation means there will be a derivative form. Derivative form means d by dx type, d2 by dx2 type form will be just there, right? So ODE is not in your syllabus. That means ordinary differential equation is not in your syllabus. In your syllabus, there is only partial differential equation, right? So definition. So in differential equation, there is a there will be a one dependent variable and one independent variable, right? So in PDE, we can see that there is a one dependent variable, but more than one independent variable can be exist here. So PDE are those equations which contain partial differential coefficient, right? And okay, partial differential coefficient, independent variables, and dependent variables, right? So there can be exist in more than one independent variables, but only one dependent variable, right? If I'm saying that z depends on x, so your derivative form will be d upon del z upon del x, right? And if there are two independent variable x and y, so derivative form will be z del z upon del x, del z upon del x, del z upon del y, del 2z upon del x2, del 2z upon del y2, del 2z upon del x del y. That means this is your first order differential derivative. This is your second order partial derivative, right? Partial derivative sign is del by del x type. So there is a notation here. Del z upon del x you can write small p. Del z upon del y you can write small q. Del 2z upon del x2 notation is r. Del 2z upon del y2 notation is t. Del 2z upon del x del y notation is s. Right? Now order. So order of the differential equation. So order of the differential equation is the same that of the order of the highest differential coefficient in it. So you can see here the order of the differential equation is the power of the highest order derivative. So is the order of the highest differential coefficient. So you can see here highest differential coefficient del z upon del x. So that means del to the power 1 is here. That means order will be 1. Del 2z, that means order will be 2. Del 3z, that means order will be 3. Right? Now, how we will form the partial differential equation? So for the formation of partial differential equation, there are two methods. First one, by eliminating arbitrary constant, and second method is by eliminating arbitrary function. So first method, method of elimination of arbitrary constant. That means there will be constant, so you will delete that constant, and in the formation there will be no constant, right? So form a PDE from x square plus y square plus z minus c whole square is equal to a square, where a and c are arbitrary constant, right? So we have our equation, right? So convert this equation into a partial differential equation. So first what we will do, we will differentiate star equation with respect to x. So 2x, x square differentiation is 2x, and if differentiation is going with respect to x, then other constant y, that means other variable, independent variable, will treat like a constant, right? So 2x plus y square 0 plus 2 z minus c, and z differentiation will be del z by del x is equal to 0. So divided by 2, so you will get x plus z minus c del z upon del x is equal to 0, and z minus c del z by del x is equal to minus x, and you know, use this notation del z by del x is equal to small p. So z minus c into p is equal to minus x. This is your equation 1. Now differentiate star again with respect to y. So to x square differentiation 0, y square 2y plus 2z minus c del z by del y is equal to 0. So z minus c into q is equal to minus 5. Our target is to delete constant c and a. So a is automatically deleted. Now it's time to delete constant c. So you can see here 1 and 2. If we divide 1 and 2, then our z minus c will be cancelled out. So, and well, remaining equation will be your partial differential equation, right? So if constant is relating by multiplication, then multiply the equations, dividing, then divide the equation, by adding, add the equation, by subtracting, subtract the equation. Whatever method is applicable, just delete your constant, right? So after dividing 1 by 2, then you will get z minus c into p upon q is equal to x upon y. That means py minus qx is equal to 0. So you can see this is a differential equation. Differential equation, that means p is equal to del z upon del x, q is equal to del z upon del y. That means the partial derivative are existing, del z upon del x and del z upon del y. So our equation is a partial differential equation, right? There is another example here. Z is equal to x plus a into y plus b from the PDE. Differentiate first one with differentiate with respect to x. So del z by del x is equal to y will be constant, so x differentiation is 1, so 1 into y plus b, so y plus b will be here. You can write del z upon del x as p. Now this is the equation 1. Differentiate star with respect to y, so del z upon del y is equal to x plus a, so q is equal to x plus a. This is your equation 2nd. Now put the value of 1 and 2 in equation 1. So you can see that y plus b, b is a constant, so you can put y plus b as p and x plus a as q. So z is equal to pq. So this is your partial differential equation, because this equation is not containing, is not having any constant, right? Now second method is method of eliminating arbitrary constant, arbitrary function. So there is an example here. So let's see the example. Form the PD from z is equal to fx square minus y square. So you need to delete f from the differential equation. So to delete f, so first you will differentiate with respect to x. So z differentiation will be z del z upon del x, and function differentiating is always f dash, right? So f differentiation will be f dash, and whatever is given, x square minus y square. Now then x square minus y square is differentiating with respect to x. So x square differentiation twice x, and y square will be 0, right? Because in PDE, there only one variable will be differentiate, another will treat like a constant, right? So p is equal to f dash x square minus y square into 2x. This is your equation 2nd. Now differentiate 1 with respect to y. So del z upon del y is equal to f dash x square minus y square, and minus y square differentiation minus 2y. So what will you do? Dividing 2 by 3. So p upon q is equal to f dash cancelled out, and you will get a differential equation, and that is differential equation is a partial differential equation, right? So this question carry 2 marks, right? So can be come in your exam. So just prepare by eliminating arbitrary constant and by eliminating arbitrary function. I will share an exercise related to these two topics in our next previous session. Right now, there is a solution of equation by direct integration. That means we are here we have the solution of the partial differential equation by the direct integration method. So we will see a question here. Solve del cube z upon del x square into del y is equal to cos twice x plus 3y. To solve this equation, we will just do direct integration, right? So first one, del cube z upon del x2 into del y. So we are just integrating with respect to x. So with respect to x, integration means del 2z upon del x del y is equal to integration of cos twice x plus 3y, and integration is going with respect to x, so dx plus fy, right? Now del 2z upon del x del y is equal to cos integration sine twice x plus 3y and twice x plus 3y integration 1 by 2 plus fy. One thing is here, if integration is going with respect to x, then you will take integrating constant to the opposite variable. That means another variable is y, so you will take up integrating constant in y form, right? You cannot take the integrating constant as in x, right? Just take as a y constant. So now del 2z upon del x del y, we have this one. Now integrating again with respect to x. So del z upon del y is equal to half sine twice x plus 3y dx plus, if integration is going with respect to x, so dx integration will be x fy dy plus gy is a new constant, right? Now del z upon del y, sine integration minus 1 by 4 cos twice x plus 3y x into fy plus gy. Now again integrating with respect to y, then we get z is equal to minus 1 by 4 integration cos twice x plus 3y dy plus x and integration of fy dy. So you are taking a new constant phi y dy and integration with respect to y, so gy dy. Integrating constant, you can take anything, but in new integrating one by one, as you are just following the integrating by with respect to x, integrating with respect to y, then you can change your constant one by one, right? Here fy, so fy we are changing into a new constant phi y, and gy integration of gy, you can write it new constant pi to y. Just mention that these are the integrating constant, right? Now Lagrange linear equation. So there is a new method, Lagrange linear partial linear equation. This is very important topic because there can be 7.5 marks question in your exam, and it will become I'm sure about it that it will become in your exam. So prepare Lagrange linear equation, right? So the equation of the type small p capital P, small q capital Q is equal to R. Small p capital P. So small p is your del z upon del x, small q is your del z upon del y, and capital P capital Q capital R are the function of x, y, z, and small p small q I have told you, right? So this is the Lagrange linear equation. So for the solution of this equation, we need to follow the 2 or 3 more steps, right? So solution of Lagrange linear equation. First step, write down the auxiliary equation. So what is the auxiliary equation? Dx upon p, capital P, this one. So dx upon p is equal to dy upon capital Q is equal to dz upon capital R. So there is, I am not sharing proof of this where it is coming from, right? So you guys just remember directly the auxiliary equation and the solution. Second step, solve the above auxiliary equation. Let the two solutions. So we need only two solution of this equation. First, you can take first two terms, then solve these this step, And second solution, you will take second and third term, then solve this integration and so on, right? So you will get two solutions. So first solution is u is equal to c1, and second solution will be v is equal to c2. So your final solution f u v is equal to 0 or u is equal to 5 is the required solution, right? So there will be there is an example here, so you will better understand by the example. Solve the following partial differential equation. So following is partial differential equation is y into q minus xp is equal to z. This is the differential equation, partial differential equation. P means del z upon del x and q means del z upon del y. So first compare with pp plus qq is equal to r. We can see that there is a linear partial differential equation because all coefficient are having the same power. P is order 1, Q is order 1. So all have order 1. So this is the linear differential equation, partial differential equation. Now we have our P. So P means minus X, Q. So Q means Y, R means Z here. Now the auxiliary equation is dx upon P is equal to dy upon Q is equal to dz upon R, right? So just write the value of X, Y, Z here. So on integrating, now before integration, you will take two terms. First two terms, so dx upon minus x, dy upon y. So now integrating on both sides, so you will get minus log x is equal to log y, and you can take a constant here minus log c. Doesn't matter, it will be c, it will be minus c. Doesn't matter, you can take anything. Just mention log c is a constant, minus log c is a integrating constant, right? So log x minus dividing the whole equation by minus 1. So log x plus log y is equal to log c. Now log x, log m plus log n. So log m into n is equal to log c, xy is equal to c. This is the equation 1. Now that means you are getting a first solution here. That means you have u is equal to c1, a first solution. Now again taking second and third term, just look at here. First two terms you have solved, and second and last term, that means second and third term. So just solve second and third term. So you will get log y is equal to log z plus log a. So log y minus log z is equal to log a. So you can write it log y upon z is equal to log a, y upon z is equal to a. So you have your second solution, y upon z is equal to a, right? You can take integrating constants c1 and c2. So from the equation 1 and 2, right? So required solution is, you can write it f u comma v is equal to 0 or u is equal to fv. You can see here f u v is equal to 0 or u is equal to 5v. So f u v, that means you have two solutions. So u is your xy and v will be your y upon z. So f u v, comma v is equal to 0. This is the required solution of the Lagrange linear partial differential equation. I will share three more questions in our next session. So for today it is sufficient. So just prepare these topics because I have covered your 7.5 and plus 2 plus 2. That means 11.5 marks. This video is okay. Okay, so 11.5 marks have covered in this video. So just prepare topic. Right. Thank you.